Here's a second example of a rational function. So I'm going to do the same thing as I did last time. I'm going to multiply top and bottom by 1 over x to the highest power, right? So here it looks like the highest power is x to the 4th. All right, so as I said, I'm going to write this in one step and pull it through. I end up with this. You are welcome to write it in 2 steps if you want. If it makes you either more comfortable or just you feel like you'll make a mistake, by all means, write in more steps. Okay, so here's my thing, right? You will notice, okay, this one is a little bit different than the previous one because I only have the x to the 4th in the top, the power in the bottom is less, right? So you can see what's going to happen here. Now that I have it in this form, I can pull in the limit because all of those limits are finite, right? But it's still not quite right? Because what's going to end up happening is all of them are going to go to 0 except for the 5. So I have a 5 in the top, but the rest of them are going to go to 0. So I'm going to put equals, but I don't want to write it that way because this is not right to write this right? I have this, and bottom I have 0 plus 0. So essentially, I have a finite number over 0, right? But that doesn't make sense. This is an abusive notation. We don't write this because this doesn't make sense. However, in our brains, that's what we're doing, right? What we have here is, again, a very similar situation to where you have a vertical asymptote, right? This is something that is going to go off to infinity. So what I really want to do is write that this equals infinity, right? It's going to grow without bound because 5 is just there, but all of these are going to get smaller and smaller and smaller. I'm dividing by a very small number. All these are going to get bigger, right? So this whole thing is going to get very small. I'm dividing 5 by a number that's progressively smaller and smaller and smaller. It's going to explode off to infinity. So you can absolutely do this way and get that result. The other thing you could do, of course, which you don't want to do because it's a pain and I'm never going to ask you to do it, is you could divide out. Well, I'm never going to ask you to do it in this particular situation, right? In Calc 2, I may ask you to do it because you have no choice. But you can kind of divide this out, right? So I could do long polynomial division and write this as like 5/3 x squared plus something x plus some rational function. And then those bigger ones, the x squared term and the x term, I'm going to take it off to infinity. I'm not going to ask you to do that. This is super easy. This is all I want to see. Once you end up with this situation where you've got a finite number at the top, in this case 5, and something that's clearly going to 0 on the bottom, you know that you have a function that's going to infinity, either positive or negative infinity, right? Depending on where we're going and why, okay? So like if it was -5, right, then it would be going to negative infinity. Yeah, so that's one. And let's do another kind. So there's one other option with these, right? So the first option was it's going to a non-zero vertical asymptote. Horizontal asymptote. We're doing horizontal asymptotes. Hello, waking up today. Then it's possible for the thing to grow without bound. Something like this. Now, you can also see that this guy is going to go to 0. But we're going to show it with the same technique. We're going to divide top and bottom by the highest power. In this case, x cubed is the highest power, right? So I do 1 over x cubed over 1 over x cubed. Write this out. And I'm going to get 9 over x squared plus 8, oh, that's an 8, sorry guys, I know it's not very clear, x cubed, hopefully that fixed it, and then I have 12 plus 3 over x squared minus 6 over x cubed. Now, when I take x to infinity, all these guys again are going to go to 0 except for the constant 12. But what I end up with 0 in the top, 12 in the bottom, right? So that's definitely 0. So this guy, this rational function, does have a horizontal asymptote. It's a horizontal asymptote of 0. So those are basically like, if you see one of these rational functions, it's going to do that. Okay? Now, of course, we want to do some more complicated examples, so I'm going to start another video with that.